All right, let's talk about everybody's favorite part of geometry. You know you love it, proofs. Everybody loves writing proofs, right? So we're gonna write a proof today for this diagram up here. We've got two givens. First given is that segment AD is parallel to segment EC. So we got AD parallel to EC. That's also shown with these symbols in geometry. If you see those arrows on those lines, that's just telling you they're parallel lines. Easy stuff, right? And then segment BD, so BD is congruent. That symbol and that symbol is also telling us the same thing that this symbol is. These are congruent segments, meaning they're the same distance. Okay, and what we need to prove is that triangle ABD, this triangle, is congruent to triangle EBC. And one of the ways we can do that is through angle side angle congruency. So what we're gonna do is we're gonna determine some angle measures through some stuff we know. We already know sides that are congruent, and then maybe find a second angle so we can prove it through angle side angle. So how do we do this? First thing is you gotta make a statement. So the first statement that we have to make is just gonna be a given, right? We're just gonna say given in our reasoning. Why? What's our reasoning for this? It was given to us, it was told to us. Okay, so what do we know? We know that BD is congruent to BC. We also know that AD is parallel to EC. So let's use this right here. Segment AD is congruent, or parallel to segment EC. Now, what does parallel lines tell us? Well, if you remember back early in your algebra courses, you had to deal with these things called transversals. So you'd have two parallel lines, a transversal cutting it, and you had all these angle measures, specifically 1, 2, 3, 4, 5, 6, 7, 8 different angle measures. And there were some patterns to be seen throughout this picture. And so you started there, right? Now we use that same knowledge that we gained earlier in previous courses. If these lines are parallel, we can look at segment DC as the transversal. And remember, it's creating alternate exterior lines, alternate interior lines. And we're gonna be using that theorem right here. This angle here is an alternate interior angle to this angle here. So angle D and angle C, we know are congruent because they're alternate interior angles. And since they're congruent, that's giving us an angle that we need to prove using angle side angle. So because these are parallel, and that was given to us, because those are parallel, we can determine the next step, that's angle D is congruent to angle C. How did we prove that? Well, we proved it because we were given the knowledge that these two lines here are parallel. And if they're parallel, alternate interior angles are congruent. Okay, so we're just boom, boom, taking those two pieces of information. And that would be our alternate interior angles theorem. That gives us the reasoning for this. Okay, next, let's go with our second given. Our second given was that segment BD is congruent to segment BC. So we're gonna go over here, we're gonna write that down. That's our statement. Segment BD is congruent to segment BC. Now what I'm gonna put over here is we have proven an angle. I'm gonna circle that. Now we've proven a side. Circle it. So we've got angle side. We need one more angle in order to prove the two triangles are congruent. So what we're looking at right here, right? Angle, we've got a side. Next thing we got to prove is another angle, okay? But before we get to that, let's talk about something here. We're looking here, I'm just setting this up, angle side angle. I got to ask myself, how do I know BD, segment BD is congruent to segment BC? Well, it was told to us, it was given. So all we got to put here in the reasoning is given. Now our last and final step is to determine one more angle that matches with this triangle and this triangle here. And you probably have already determined it. It's the vertical angles that you see right there in the middle. Vertical angles are always congruent, so this angle is the same as this angle. I'm gonna mark those double because we've already marked single up here, right? So vertical angles are always congruent. So what we can say is angle ABD, is congruent to angle CBE. Angle CBE. BE. And that is our last and final angle to prove. So we've got angle, side, angle. How do we know this? This is from the vertical line theorem, or excuse me, vertical angles theorem. Now, last and final, we got to tell our last statement. Our last statement is going to be that triangle ABD is congruent to triangle ABC. So triangle ABD is congruent to triangle EBC. How do we know that? Because of angle, side, angle congruence. All right, so basically when it comes to proofs, all we are doing is we are making statements that, think of it as a puzzle. Start in one part, work to the next part. That will usually, not always, but usually help you determine the next position, the next part that you need. And once you have enough to prove that two triangles are congruent, you're done, okay? So you're always gonna be given something. That piece of information given to you should be enough for you to determine what you're being asked to prove. Hopefully this makes sense. I know it's a lot of writing. It's not everybody's favorite part of geometry, but somebody's got to do it. And it's just going to help you have a better understanding of all the different rules that you're learning. Geometry, you're throwing a lot of different rules. Some of them are kind of common sense, I'd say. Others you have to be taught and then memorize. So just study, and good luck on your upcoming test.